What's up guys, my name is Heinrich and welcome to Pardoned. Today we're going to take a look at making a poor old defenseless dummy for our hero to beat up and destroy. We are right where we left off in the last video. We'll start off by creating a new empty game object that we'll call Combat Dummy. We can then reset its transform. This game object will hold 3 other game objects. One that will be our alive state, and 2 that are the 2 pieces that the game object breaks into when it is destroyed. So we can create a child game object and we'll call it alive, and then another child game object that we'll call broken top, and one final child game object that we'll call broken bottom. We can then select all 3 of the child game objects and head over to the inspector. Click on add component and search for sprite renderer. By clicking this, we have now added a sprite renderer component to all 3 of the child game objects. Under the sprite renderer component, go to additional settings and click on the sorting layer dropdown. Then click on Add Sorting Layer. In the Sorting Layer menu, click the little plus sign to create a new layer. We will use this layer for our enemy sprites. Drag this layer to right above our player sorting layer. This means that the enemy sprites will appear behind our player sprites. Then just go ahead and rename this to Enemy. We can then select all 3 of our game objects again and change the sorting layer to the enemy layer. We are then just going to click on our broken top game object and change its order in layer to 1 so that it will appear in front of the base. We can then select all 3 game objects again, and this time we're going to add a rigid body 2D component to all of them. While we have all 3 of them selected, change the gravity scale to 8. We can then select our broken top game object and change the collision detection from discrete to continuous. We do this because this is the game object that we're going to send flying when the object breaks, and we don't want it accidentally flying through any walls. We can then select our alive and broken bottom game objects and tick the freeze rotation on the Z-axis box. Now let's go ahead and add sprites to our game objects. We can click on the alive game object and drag in the first sprite of our combat dummy sprite sheet. For the broken top, we will use the 3rd sprite, and for the broken bottom, we will use the 2nd sprite. Now we can just select the parent game object and drag our dummy so it's next to our player. We can now add the colliders. Click on the alive game object and then click on add component and search for box collider 2D. Add it and then click on the edit collider button in the inspector. In the scene view, edit the collider to fit the object better. We can then do the exact same thing for the broken bottom game object. So click on it and add a box collider 2D, and then disable the alive and broken top game objects by clicking on them and unticking the little box next to their names in the inspector. Now we can see our broken base clearly and set the collider appropriately. We can now disable our broken bottom and enable our broken top game objects. And this time, instead of adding a box collider 2D, we're going to add a capsule collider 2D. This will allow the object to roll a little bit depending on how it falls. We can just edit the collider to make it fit a bit better, just like so. Now just make sure all of our game objects are enabled again. We can now click on our combat dummy game object. In the inspector, click on the tag dropdown and click add tag. We can then click the little plus symbol and add a new tag. We'll just call it enemy. We can then expand the layer section and add another layer that we'll call damageable, and another one called dead. We can then select our alive game object and set the tag to enemy and the layer to damageable. And then for our broken top and broken bottom, we can set the tag to enemy and the layer to dead. Now let's click on Edit, Project Settings, and head into the Physics 2D section. Here we can see our layer collision matrix. What this is a series of tick boxes that let us control exactly what should and should not be able to collide. We don't want our player layer to be able to collide with our damageable layer, so we will find player and damageable and click the box where the 2 intersect. We're also going to make it so that dead and damageable don't collide, damageable and damageable don't collide, player and dead don't collide, and finally, dead and dead don't collide. We do this so the player can walk through all the different parts without pushing them around, and so that the parts won't stack on top of each other. We can now close this window and click on our alive game object again. We can click on add component and then add an animator component to it. Navigate to the animation controllers folder and let's create a new animator controller. We'll call it dummy AC. Go ahead and click on the alive game object again and drag the controller into the controller slot. Now let's pull up the animation window. Before we create the animations for the dummy, let's head into the animations folder and just do some cleaning up. I'm going to create a folder called player and just move all the player animations into it. I am then going to create another folder called combat dummy, and I'm going to put all the combat dummy animations in here. So let's click on the alive game object again, and in the animations window, let's click create and then navigate to the combat dummy folder and name the animation idle. We only have one sprite for this animation, so we don't need to worry about the sample rate. Just go to the sprites folder and drag in the first sprite to the animation. We can then create a new animation and call it combat dummy _ damage _ left. Change the sample rate to 15 and then drag in the last 5 sprites. This is the animation that will play when the dummy gets damaged from the left. We can then create another animation, and this time it'll be combat dummy _ damage _ right. We really should have called our idle animation combat dummy _ idle, but we won't worry about that now. Set the sample rate to 15 again, and this time drag in the sprites from the 4th one to the 8th one. Now let's head into the animator window and click on our alive game object. We'll start out by creating our parameters. The first one is going to be a trigger, and it's just called damage. And then we have a boolean that we'll call player on left. As you can see here, I typed it with a capital P, but just go ahead and make it a lowercase p, as I'm going to do that later in the code. You can just arrange the states like this. We want our default state to be idle. Then we're going to make a transition from our idle state to our combat dummy damage left state. We'll make sure that has exit time is not ticked, and then we can expand the settings and set the transition duration to 0. Under conditions, our first condition will simply be the damage trigger, and our second condition will be player on left must be true. We can then make a transition back to the idle state, and this time we want exit time to be ticked and we want exit time to be set to 1, and transition duration must be set to 0. Next, we can make the same transition from our other damage state to our idle state. Finally, we can make the transition from our idle to our combat dummy damage right state, and the conditions this time will be the trigger and player on left must be false. We can then untick has exit time and set the transition duration to 0. Everything is now set up, so let's head into our scripts folder. Create a new script and call it combat dummy controller. Let's open it up in Visual Studio and get started. First, we need to delete all the pre-generated code again, and then we can start by declaring some variables. First, we're going to make a serialized field to hold a private float max health. This will be the maximum health of the dummy. Next, we'll declare a private float current health that will hold the current health of the dummy. Next, we're going to declare a private player controller called PC. This will hold a reference to the script attached to the player and will be used to get the direction the player is facing when the enemy is damaged. Next, we're going to declare 3 variables to hold references to the 3 child game objects. So we'll say private game object, and the first one is called alive go, and the second one is broken top go, and then the third one is broken bot go. Now we're going to need 3 variables to hold references to the rigid body 2D components of the 3 child game objects. So we can say private rigid body 2D, RB alive, and then RB broken top, and finally RB broken bot. Next, we want variables that will hold references to any of our game objects that are animated. In this case, only our alive game object is animated, so we can just say private animator alive anim. Okay, now we can initialize all of our variables in the start function. We'll start off by setting current health equal to max health. Then we can set our reference to the player controller script with PC equals gameObject.find player.getComponent of type player controller. What gameObject.find player does is look through the hierarchy and return the first game object it finds that has the name player. This is fine to do seeing as we only have one player. GetComponent will then return the component that we're looking for, in this case the player controller script. Next, we're going to get the references to our 3 child game objects by saying alive go equals transform.find alive.gameObject. This is doing basically exactly the same as we just did for the player controller, but instead of looking through the whole hierarchy, it will just look at the children game objects of the object that this script is attached to. So we can then also say broken top go equals transform.find broken top.gameObject, and broken bot go equals transform.find broken bot.gameObject. Now that we have all 3 of these references, we can use them to get the rest of the references, starting with the animator. So we'll say alive anim equals alive go.getComponent of type animator. Then next we can do our rigid body components. So we can say RB alive equals alive go.getComponent of type rigid body 2D. And RB broken top equals broken top go.getComponent of type rigid body 2D. And finally, RB broken bot equals broken bot go.getComponent of type rigid body 2D. Finally, for our start function, we just need to make sure that the alive game object is enabled and the two broken game objects are disabled. So we can say aliveGO.setActive true and broken_top_GO.setActive false, and lastly, broken_bot_GO.setActive false. Now let's move on to our first real function, the damage function. This is the function that we need to have on every one of our game objects we want to be able to damage. The fact that we're using a send message to call the function means that we can have a unique reaction to taking damage for different scripts. Enemies can get knocked back when they take damage, and pots can explode. It's a very powerful way of doing it. So we can say private void damage. This function will have one input parameter, and that is the damage amount. So we'll say float amount. Inside the function, we can start off by saying current health minus equals amount, so that our object actually takes the damage. Next, we quickly need to jump into our player controller script and make a public function that will return the direction we are facing. So we'll say public int, because facing direction is an int, and we'll call it getFacingDirection. Inside the function, we simply need to say return facing direction. We can then hop back to our dummy script and just create a variable to store the player's facing direction. So we'll say private int player facing direction. We will also create a private boolean called player on left. Then in our damage function, we can say player facing direction equals pc.getFacingDirection. Now we need to let our animator know what side the player is on so that the correct animation can be played. So we'll say if player facing direction equals 1, then set player on left equal to true. Else set player on left equals false. Then we can pass this to the animator with aliveAnim.setBool player on left. And then we also need to trigger the damage animation, so we'll say aliveAnim.setTriggerDamage. We can now start taking a look at applying a knockback effect on the dummy. So let's come up to the variables and just declare a serialized field that's going to hold a private bool apply knockback. With this, we'll be able to turn off knockback in the inspector if we want the dummy to stay where it is. So back in our damage function, we'll say if apply knockback and current health is greater than 0.0f, then we call the knockback function. Then right after this, we can say if current health is less than or equal to 0.0f, then die. Let's go back up and declare the rest of the knockback variables. We'll start off by declaring two more serialized field floats. The first one is knockback speed x, and the second one is knockback speed y. This is the velocity in the x and y direction that we're going to set the rigid body to when we apply knockback. Next, we'll declare a private bool called knockback. This will keep track of if the dummy is currently being knocked back or not. We also need a private float called knockback start. And finally, we'll declare another float called knockback duration. Now we can write the knockback function with private void knockback. And then inside the function we can say knockback equals true, and then knockback start equals time.time. Then we can set our velocity with rbalive.velocity equals a new vector 2 with knockback speed x times player facing direction for the x and knockback speed y for the y. Next, we're going to make a private void function called checkKnockback. This function will take care of stopping the knockback once a certain amount of time has passed. So inside the function we can say if time.time is greater than or equal to knockback start plus knockback duration, and knockback is true. Then we set knockback equal to false, and rbalive.velocity equals a new vector 2 with 0.0f for the x and rbalive.velocity.y for the y. Now we just need to come up and call the knockback function here where the dummy gets damaged. And then we come up to the top and create the update function, and then inside that we call the checkKnockback function. Now we can work on what happens when the dummy dies. So let's come up to our serialized field floats and add 3 called knockback death speed x, knockback death speed y, and death torque. This will be used so we can knock the dummy back further when it breaks. The torque is going to be used to make the top part spin. So let's come back down to the bottom and create a private void function called die. Inside the function, we'll start off by enabling the broken game objects and disabling the alive one. So we'll say aliveGO.setActive false and broken_top_GO.setActive true, and then finally broken_bot_GO.setActive true. Now, because we have been moving the alive game object with the knockback, we need to say broken_top_GO.transform.position equals aliveGO.transform.position. And then also broken_bot_GO.transform.position equals aliveGO.transform.position. This will just make sure everything lines up. Now we can add the knockbacks. So we'll say rbBrokenBot.velocity equals a new vector 2 with knockback speed x times player facing direction for the X and knockback speed Y for the Y. This will make it so that the broken base game object does the same little hop backwards it usually does. And then we can say RB_broken_top.velocity equals a new vector2 with knockback death speed X times player facing direction for the X and knockback death speed Y for the Y. This will make it so that the broken top gets knocked back by a different amount. I'm planning on making it bigger. Finally, we can say RB_broken_top.add torque to add the torque with the parameter death torque times negative player facing direction, and we'll say force mode 2D.impulse. This will cause the broken top piece to rotate once it breaks. And now we can just come up and call our die function when the dummy gets broken. We can now jump back into Unity and click on our combat dummy game object and then drag in our script. And then we can set all of our variables. We'll set max health equal to 50, knockback speed X to 10, knockback speed Y to 5, knockback duration to 0.1, knockback death speed X to 15, knockback death speed Y to 8, death torque to 1, and then finally we can tick apply knockback. Now all we need to do is head to our player game object and under the combat script select damageable in the what is damageable variable dropdown. If we run the game now, we can see that the enemy reacts to being hit and eventually breaks, sending the top part tumbling and flying. We're basically done. The last thing we need to do is create the hit particle that plays when the character makes contact with the enemy. We'll start off by creating a new empty game object and calling it hit particle. We can then reset the transform. Next, we can import the sprite sheet for the particles. You might have already done this, I just forgot to do it at the beginning. We can then click on it and change all the settings like we usually do. In the sprite editor, we can slice it and make sure it is still on grid by cell size. This time the pixel size should be 128 by 128. Hit slice and then hit apply. We can now click on the hit particle game object and add a sprite render component. We can then drag in one of the sprites just so we can see the game object. Under additional settings, we can set the sorting layer to player and then change the ordering layer to 10. We want it to be above everything else. Next, we can add an animator component, and then in our animation controller folder, we can create a new animator controller and we'll call it particle AC. We can then drag this controller into the controller spot of our game object. Let's drag our animation window back up and then create a new animation. Navigate to the animations folder and call it hit particles. Set the sample rate to 15 and then drag in all the sprites. Now we can head into our scripts folder and create a new script called particle controller. Open it up and go ahead and delete all the pre-generated code like we usually do. All we need to do in the script is write a private void function called finishAnim. In this function we will say destroy game object. So when this function gets called, the object the script is attached to will just get destroyed. If you're planning on having lots of particles happening rapidly after each other, I suggest using object pooling for this as well. We can then head back into Unity and drag the script onto our particle game object. In the animation, we can then add an animation event at the end and make it call the finishAnim function. Now let's head into our prefab folder and drag the particle object into it. While we're here, we can also drag down our enemy dummy game object. Just go ahead and reset its transform before you drag it in. Now let's go back to our combat dummy controller script. At the top, we can say serialize field and then private game object hit particle. This will hold a reference to the prefab that we just created. Then in our damage function, we can say instantiate. The thing we want to instantiate is our hit particle, and we want to instantiate it on aliveGO.transform.position. For the rotation we want to instantiate it at, we'll say quaternion.Euler, and the parameters will be 0.0f for the x, 0.0f for the y, and random.range from 0.0f to 360.0f for the z. So this should instantiate the particle effect on the dummy's position with a random rotation. So now let's run the game and test it out. And there you go. Our mighty hero now has a super evil and defenseless enemy to beat up as much as he likes, complete with sparks that fly every time he gets hit. I hope you guys found this tutorial useful and managed to learn something from it. Next, we're going to take a look at creating a basic enemy that can actually fight back. I hope you all have a lovely day.